In this video we're going to take a look at some of the web challenges from the HackTheBox Cyber Apocalypse 2021 CTF. The first challenge we'll take a look at is Inspector Gadget. So there were no files to download for this. Let's take a look at the description. It says, Inspector Gadget was known for having multitudes of tools available for every occasion. Can you find them all? So we need to start the challenge. Let me launch the Docker container. We get the IP and port that we can connect to. Might take a little while to boot up. So the challenge loaded and we have this page. There's no links or anything on it. We can see the beginning of the flag here, and then we just have an animation in the background. So we can do Control and U to view the source, and we'll notice right here that we have a comment which looks like part of the flag. We can see the underscore in it, so there's part of the flag inspection, and we have the HTB part already. So where else should we take a look? Let's have a look at the JavaScript, and we'll see here's useful information, and also the CSS. If we take a look in there, we have can reveal. So the full thing is HackTheBox inspection can reveal useful information. So we just put that all together into a string, submit it, and we've got our first web flag. The next web challenge we're taking a look at is called MiniSTRyplace, and we can see that the str is capitalized, giving us a hint. It says, let's read this website in the language of aliens, or maybe not. I'm not sure, is that a typo or some kind of hint that I'm not getting, but so we have a server that we need to launch. We have a downloadable part. Let's go and take a look at the downloadable part then. So we have some different files we could download here. I'm going to open this up in Codium so that we can have a look through the code. We can also build this up, the Docker file. So let's have a look here. Where's the challenge? Index.php. Alright, before we have a look at the code, let's launch this as well. So we'll run the build Docker script. See, it successfully builds this. It's called LoveTalk. I don't know, I haven't actually done the LoveTalk challenge. Maybe this is related to this challenge then. And we can see that's launched. It's all up and running. It's on port 1337. So if we go now to localhost 1337, and we'll get the same page that we'll get then if we go on the server side. This is just handy. It means that if there's any issues on the server side in terms of latency, we don't need to worry about it. It also means that we can potentially modify the code as well. So if we wanted to add in more console.logs or something to have a look and see what's happening in the background, for example, if there's some kind of filter in place stripping out characters, we might want to try and build up we might want to try out some different encoding types and things like that to see how we can bypass it. So by printing out what the server's actually seeing after it's done its validation, after it's gone through its blacklist or whitelist, whatever, then we'll be able to see if we're getting close to our payload working. So that's all up and running. Let's have a look at the code. And if we check the code here, it looks like a classic LFI. We can include a local file here, so you can see that it's actually trying to use string replace to replace any / slashes that we insert here. And essentially what it's saying here is it wants us to provide a language, either English or QW. I don't actually know what, I'm not too sure what that is. It wants us to provide a language here anyway, and if we don't provide a language, it's gonna assign a random one out of those two, and it's going to strip any / slashes we enter there. So if we go, and I mean, we know that we have the flag in this directory, so what we'd be aiming to do is, let's go to the site and we select the language there. So we'd be aiming to say / slash flag, and that's the file we want to include rather than the language PHP file. But obviously these / slashes are being excluded, so running that is the same as running just equals flag, which isn't doing much for us. So we could go and have a look for some LFI filter bypass checks. There are different encoding types and stuff. We might want to try and encode the slashes. I'll show you the way that I solved this. Let's go over to Burp Suite first of all. In Burp Suite, you see we have quite a lot of noise in Burp Suite here, so I'm gonna update the scope. Let's go to our target And for now, let's just say we only want this 127 address to be counted, so we'll add that to the scope. And then we can go to our proxy, and in our HTTP history we can just say that we only want to show in scope items, and then it'll only show these items here. And similarly, if we wanted to only intercept those as well, we can go to options and just say we only want to intercept client requests if they're in scope, if the URL's in scope, and then we won't have to deal with that sort of stuff. So yeah, we could go and take one of these requests then, send this to the repeater, and go and play around with some different types of encoding here to see if we can get this to work. The way I ended up solving this was to add in some extra slashes. So if we put in here dot dot slash dot dot slash, we know that it's doing a string replace here. Let's go and take a look at an example. So this is the example string replace. So if we insert a string and it's dot 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 slash slash dot 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 slash slash, it's going to see this dot dot slash and it's going to remove it, and it's going to see this dot dot slash and it's going to remove it as well, and we're going to be left with exactly what we want. So let's go and test that out. If we go to the repeater and send that off, we get our fake flag for testing, which is what we have right here, which means we can go and have a go at this on the server as well. So I already have this up and running. Let's take a copy of the address, and again select a language, and we're going to replace this then with dot 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 slash slash dot 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 slash slash and then flag, and then we get our flag. The next challenge is called curl as a service, and it says it's a brand new alien application built so that humans can test the status of their websites. However, it seems that the aliens have not quite got the hang of human programming and the application is riddled with issues. So we can launch a Docker container for this, and we also have some files to download, so let's go and take a look at the files. I will admit that this challenge took me an embarrassingly long time to solve considering how simple the solution is, but let's have a look through the code here. So let's go back to the index.php here. So there's a couple of routes. We have a get request we can make to the home directory, and that's going to call this curl controller at index, and we have a post request to API curl, which is going to call curl controller execute. So let's go and have a look at the curl controller, and we'll see in here then if we call index, it's just going to call view. It's basically going to display the page. If we call execute, which was by sending a post request to API curl, then it's going to take in a post parameter, which is IP, and it's going to assign the URL to equal that, and as long as that's been set, it's then going to create this new command model with the URL, and then it's going to JSON encode it and call exec as well, command exec. So we can go in and have a look at the command model and see that in constructing here, it's going to construct a command, it's going to take in our URL, and it's going to append that to curl-sl, and it's going to wrap our URL inside this escape shell command. So you can see that I've got this print statement here. This print statement wasn't actually here to begin with. I put this here because since we have the Docker file, we can run this locally, and I wanted to find out exactly how this escape shell command was treating our input, and the best way to do that then is just to print it out whenever the server's processed it, or you could just create like a local PHP file to test out the same thing. But let's go and, so it looks like some command injection here was my initial thinking, that I mean obviously we have this escape shell command, but if we were able to append something to this curl command, it'd be executed right down here. So if we were able to append something to list the directory, we'd be able to see where the flag is or cat out the flag. But obviously we would have to overcome this escape shell command. So let's launch a Docker instance and we'll build the Docker, and we'll go and test this out and have a look a little bit further into the escape shell command. So this is going to run on port 1337. Let's go to the address 127.0.0.1 1337, and we have the curl prompt here, so we could try and enter something in. Now if I try and enter in even just the IP address, we get illegal characters detected. So if we Control and U to go and have a look at the source, and there's a JavaScript file here which we could have looked at in Codium as well because we have access to all the source code. But if you go and have a look at this, essentially this is checking to make sure that it's a URL. So, but obviously this is JavaScript, so as long as we can modify the traffic with a proxy, we don't need to worry about that. So if we swap over to Burp, let's go into the HTTP history. We can see that we made the GET request. Now, it's not even attempted to make the POST request because the client-side validation failed. So let's try and enter in an actual web address, and you see there it didn't come back with any output, but it looks like the command went off okay. We can see it here in the HTTP history. So if we send this to the repeater, and now we can go and just play around with this. So the reason that I'd added the print here, if we hit send, and let's maximize the window so we can see it a little bit better. So we have, let me send that off again with another line. So we can see it comes back here with our command. You can see it's added a backslash to the end of that. Let's try and insert in here. So we send off the IP, and if we wanted to append to that and say we want to list the directory, list the files in the directory, see that's not actually come back. Let's try and URL encode that. And you can see that it's come back, but it's added the backslashes before our and symbols, so it's escaped those. So whenever that runs in the terminal, it's not going to execute the ls command. Let's undo that. So it was at this point that I started to look into the function. If we go and take a look at this GitHub, you can see there we've got the curl section already, but let me just scroll to the top. It describes here the difference between escape shell command and escape shell arg, where the escape shell command will ensure that the user can only execute one command, but can specify an unlimited number of parameters, can't execute a different command, and escape shell arguments will ensure that the user can only pass one parameter to the command and can't specify more than one. So let's go back down to our curl section there, and we can see then with the curl example that although the escape shell command will ensure that we can't enter any additional commands after that, we can pass any number of arguments to curl. So in this example here, they use a -f, which is, I think, will this upload? It's to try and upload the local password, etc password file to example.com. So if we controlled this site and we were able to access it, we could upload that to our server. The problem is in this case that we don't have an attacker controlled site which the machine that we're testing is going to be able to connect back to, because it's not going to have full internet access, and we don't have any other machines on the local network which we have control over. So I did play around with this for a while but didn't get anything working. Let me also just bring up some documentation from the official PHP docs, and in here it explains that these various characters, all of these different special characters, and then also hex values between, also these hex values will be escaped if they're not paired. And I think there was a warning somewhere. Yeah, here's the warning. So escape shell command should be used on the whole command string, and it still allows the attacker to pass an arbitrary number of arguments. For escaping single arguments, pass the escape shell arg. So yeah, at this point I decided to have a look at some other curl commands that we have available, some other flags should I say. So if we go and have a look at the man curl docs, I basically had a look through all of the different parameters that we could provide, because at the moment it's passing in the SL, which will make this silent. I will note that if we go back, and let's go back to burp and pass in -v before we send that, and you'll see that it comes back with the curl version, so we are able to retrieve data. So I was playing around with that for a good while. I didn't actually get anything, I didn't actually get that working, so let's have a look at another site here. And if we have a look here for curl, so if we have access to curl, here's some things that we can do with it, and particularly here is the option to read files, where it says that we can just provide the file prefix to load a file. So maybe you'll see where this is going. I wasted quite a lot of time trying to get other things working before moving on to this, but if we actually just try here and load the flag with file instead of HTTP, let's try that now, and you'll see we get back our fake flag, so we'll be able to do that against the server. Note that even once I found this as well, even once I found the correct command, I still had some problems because I was sending an extra new line at the end, so you don't get anything back. So most of the things that I was trying initially, I was getting nothing back, and because I had this new line here. So just something worth bearing in mind: if you have that new line, you might not get back the output that you expect. But that's it all working locally. So now that we know it works locally, let's go and test it out against the remote server. We've already got the Docker instance running, so let's just copy that. And again, we can just put in, well, we should just be able to put in the full thing here. Let's do file and then flag, and then we get back our flag. So yeah, really easy challenge. Took me way longer than it should have, but that's how you solve it anyway. The next challenge is called BlitzProp, and it says that it's a tribute for the legendary alien band called BlitzProp. And again, we have some downloadable files, and we can launch a Docker instance. So I've already launched the Docker instance. I'm going to open this up now because I tried to build the Docker container for the downloadable files and get things working locally first of all, and it didn't have the same layout, and things that were submitted weren't working. So I'm not too sure what the issue was. I just decided to work with the remote service here anyway, which is fine. But let's go and open up the code and take a look at it. With the code open, just before we actually dig into that, let's test out the functionality. So we have a box here which we can enter some text into and submit it. So let's just try and submit a script. Can't see where the cursor is on it. And just see if anything happens. We submit that and we get a message back saying please provide us with the name of an existing song. So we have these 4 songs here. Let's take a copy of that and paste that in, and then we get hello guest, thank you for letting us know. Let's see out of interest if we append something to that, do we still get the same message back? It looks like we do. So as long as our text is in there, we'll meet the condition by the looks of it. So let's just try and insert something after that as well. And we submit that, but there's no change anyway. It's still saying thanks for letting us know. So we could go and have a look in Burp Suite and have a look at the requests and see that it's actually sending this off as a JSON object with the song.name parameter being set. So let's send this to the repeater. So if we want to go and play around with this later and see if we can inject more things, we'll be able to easily do that here. And with that out of the way, doesn't look like there's much other functionality there to test out. So let's go and have a look at this code as well. This is our index.html page. We don't really have too much else here. So inside the challenge folder, which is all that we're interested in, we've got our roots with index.js, and then we've got our static folders with JavaScript images and stuff like that, and then just our index.html. So the only things of interest really are our index.js and index.html. So take a look at index.js and we'll see that we have some libraries being used here. So path, express, pug, and flat. If we make a get request to the home directory, it'll just resolve this views index.html that we were just looking at. And if we make a post request to API submit, then which is what happens whenever we send off the song name as this JSON object, then it's going to check to see if song.name includes one of those song names. You can see that variable set here, and if it does, it's going to call pug.compile. It's going to return a response with pug.compile and then print out hello user, thanks for letting us know, and it's setting the user to guest right here. Otherwise it'll just print this out to say please provide us with the name of an existing song. So we need to go and have a look into this pug.compile and see what it's doing. The first site I looked at here again was the HackTricks site, just to see if there was a cheat sheet here of some commands that we could enter. So let's load that up and see what I initially tried. So if you go and have a look at that, there are a couple of commands that we can try here. There are various server-side template injection commands for different types of libraries, different languages and things like that. So I went and tried to just see if it keeps loading the new section, so it's moving my screen down. Where's it gone? So I tried to just see if we could inject something like this in burp, and I mean the problem is here that, well, we need to keep the song name in anyway. The problem is obviously that it's not reflected back here anyway, so we'd be hoping to see 49, but we need it to be reflected back. I was at first, I thought, without looking at the code too closely, I thought that we needed to add another parameter, so name, which we would be able to add in some code to execute, because it was trying to load the name here. Obviously it comes back with guest, but so I was trying that to begin with, didn't really get anywhere. But if we, let me go back here, let's check out another link which was recommended to me by a teammate. So as we can see here, this article describes how to trigger RCE in two well-known template engines using a new technique called abstract syntax tree injection, and the two libraries are Pug and Handlebars. So the first section talks about how to do this in Handlebars. Let's go down, skip straight down to the Pug section, and there's quite a bit here, you can read about it. I'll skip a little bit down towards the actual vulnerability, and we can see here, so Pug works as shown in the graph above. Unlike Handlebars, each process is separated into a separate module. Okay. In the compiler of Pug, there's a variable that stores a line number named Pug debug line for debugging. If no .line value exists, it is added to the buffer, otherwise it's passed. And it's always specified as an integer, but we can insert a string into the node.line through AST injection and cause arbitrary code execution. So this is the important bit we need to note. This is what we need to do, and it gives a breakdown of this, showing how the pug.compile works. So if we go back to our code, this is what's being called here, pug.compile. So you can go and play around with this locally and see and print this out and have a look a little bit more what it's talking about. It does give a proof of concept here, which is an example here at the bottom, where they provide the URL. They're posting this to vulnerable. We're needing to post it to API slash song or something, I can't remember what it was called, and then it basically sends off this JSON object where we have the proto block. It's requiring the child process and then executing a command, and then they've just specified the command in here to get a reverse shell. So I basically just copied and pasted this and tried to make some changes to it. So let's go and have a look at, let's go and try that out. So we need to put in our server address and port number here as the target URL, and then we also need to have API submit as in the URI, and just leave this as default. But rather than what I initially tried to do here was just to cat flag.txt to see what would happen. So let's just, or just cat flag, we know it's just called flag because it's we have a local copy of it. So we'll just try and do cat flag to begin with. We also need to remember that we need to send off the song name, so we need to add in here as well song.name is equal to, and then we need to get a valid song name. So let's go and grab one of the song names. The Goose Went Wild, and then all we'll do here is just print out the, let's return this into a result. So we'll say result is equal to request.post, and then we'll print out result.text and see what we get back. Let's try and run that. So it takes a little while to come back. This is exactly what happened to me, but it looks good because what we see here is that command failed, can't open flag, no such file or directory, which means we've got execution, we just aren't able to, we just don't have the flag in that directory, so we need to go and have a look around. So what I tried to do now then is just, the logical next step would be to change this to ls, The problem is, if we try and run this again now, the problem is it'll run the command, but it's not actually returning the output. So then if we go and try and change this again, and we can try and say ls to output, save that again, send it off, and then if we save it to output, we might be able to just go and open the output file in the browser and view it, but we'll see that we can't do that because the permission is denied. So what we can do is we could go and have a look around the site, right? So if we go and open up the source, we could go and see, well, we've got the static folder. Why don't we try and write to static? I'll go back and say write this to static/output, and if we try and run that again, and it didn't return any output, but that's a good sign. That means it's completed the command successfully. So now if we go and take a look at static/output, we'll see that it's actually returned the directory listing. And the reason we weren't able to print flag, well, one of the reasons is because we didn't have the right name anyway. So we could have potentially used just like flag with an asterisk instead, but even if we did cat it out, it wouldn't actually return the output for us. So we would want to cat it to, oh, we can just copy it. So let's go and say copy flag. Let me get the actual name of it. So we can just copy it to static flag, and then rather than printing out result.txt, we could now make a get request to the same. So we could you don't need that, I'm just doing that so I can use the success message, and we'll assign our flag is equal to requests dot get, and then we'll make a get request to the target URL plus static/flag, and we want to get the response text, and then we want to print that out as well. So now if we try and run that, let me clear the screen a bit. And you can see it takes a little while to come back, but we get back our flag, HackTheBox, pollute with style. The next challenge is called Wild Goose Hunt, and it says outdated alien technology has been found by the human resistance. The system might contain sensitive information that could be of use to us. Our experts trying to find a way into the system. Can you help? So again, we have a Docker container we can launch here, which we've already got running, and we can download the files locally as well. So we'll launch a local Docker instance to get things working locally first of all. It can be quite a bit faster doing that, and we can potentially modify the server-side code as well if we want to see how our data is being processed. So let's also open up the code as well. And the first thing you'll probably notice here in the entry point, it's setting up a Mongo database, and it's inserting in there an admin with the password, which the password is the flag, so it looks like that's what we need to retrieve. So before we look at the code any further, let's just go and open up the site as well. We can load up the page here, and we have some links which don't appear to go anywhere. So let's try and log in. We've got the username and password here. We'll just put in admin, and we get back login failed, which we know is going to be the case because we didn't enter the flag as the password. So if we went back and grabbed this fake flag instead and submit that as the password, then we get login successful. So it looks like the goal here is going to be SQL injection, or no SQL injection in this case, so we might go and try and play around with some of these parameters. Maybe we'll go over to Burp Suite and send it to the repeater so that we can easily play around with these parameters as well. And that means we can try some different things in here and see what responses we get, if we can trigger any errors. And obviously we're going to want to go and have a look at some cheat sheets, SQL injection cheat sheets. Maybe check out PortSwigger. I don't know how much stuff they've got around MongoDB, but let's go back to the source code here anyway. So we might want to go in here and have a look to see if there's anything that we're missing. If we go in and have a look at let's have a look index.js here, and we can see it's also using Pug here, which was used on another challenge. It looks like it's just used for the viewing, for the UI maybe. And we have our Mongo database being connected to here. The Heroes is the name of it. Let's go and have a look at the models. So we have this user.js model. If we go over to actually index.js, so this is where the bulk of our code is. We have our GET request, which we can make to the home page, and it'll just return the index, or we can post to API login, and we submit the username and the password. So it's returning this user object, which you can see here is included from here. It's returning a user object which contains a username and a password, both type string, and then it has a collection here, user, and this is set to export. Let's go back and take a look again, and it's going to check then if it finds that user. If it comes back with a 1, then we'll get the successful, otherwise we'll get login failed. So at this point I would probably start googling around looking for MongoDB injection cheat sheets and previous CTF walkthroughs. Luckily my team member referred me to a walkthrough which should help with this challenge, so I'm going to open that up now. And if we're going to take a look at this right up, then this is from the 2016 CTF and has a similar challenge. So we have a login here with a MongoDB on the back end, and the solution that they use here in order to bypass the login check is to pass in objects or arrays. So let's go back and just take a copy of this and try and submit this in our repeater. We need this as a username, and if we send that off, oh, we get invalid username and password because I didn't type in username correctly. But if we type that incorrectly, we get back login successful, welcome back admin. So that's great, but obviously being logged in isn't too much use to us. We actually need to be able to retrieve the flag, and that's the exact same case with the article here. So in this article they use some regex to perform blind SQL injection, and essentially they loop through each possible character here in a password, and then if it returns, in this case, a status code 302, then print out that character or print out the characters so far, and keep doing that until you've got the full flag, which they explain a little more here. So they also mention that some characters have been left out so they don't break the regex. So I grabbed a copy of the script and went and made some updates to it. So obviously updated the flag format and the address first to the local address that we're testing out, and mostly this is the same. I changed the loop slightly because I noticed whenever we're testing this against the server it's quite slow and it didn't have any uppercase characters in it, so I changed this to lowercase, and we check all digits and also just check the underscore before. If you check the code here, they check the underscore towards the end, so they check every ASCII letter, lowercase and uppercase, and every digit before, and all of these other characters before they check the underscore, which is most likely to come up in this flag. So we check that first, check all the lowercase, check all the digits, and then check the rest. And each time we're sending off the greater payload, so every time we find a character, we're starting off by sending this, and then we're looking for the next character, and say we find that that's an A, then we'll send off this, and we just keep doing that until we get to the final curly brace, and then we'll print out the flag at the end. So let's run this against the local server first of all, and you'll see it very quickly gets the flag back, the fake flag for testing. So now we want to grab the server address, and we can just go and place that in our Python code and run the script again. And you'll see straight away it's not going to come back as quick as the local server did. At first, whenever I was running this against the server, I wasn't sure if anything was happening at all, so I had to go and update the code to keep printing out the responses. But it is running, it just takes a little while to go through them. and it takes a lot longer if you're checking for all the uppercase characters and checking for underscores after at the end. So I'm glad that that's not the case this time. I'll speed up the process here, I'll let it run for a few minutes and then come back. So yeah, I left it running there. It took about 10 or 15 minutes to complete, and then we got a flag. I actually, whenever I was solving this originally, I saw the BEF here, and then just guessed that the rest was going to be 0 R3, and just submitted that, so it stopped the Docker instance towards the end of it. And that has been the Wild Goose Hunt challenge. The next challenge is called E.Tree, and it says, after many years where humans work under alien commands, they have gradually been given access to some of their management applications. Can you hack this alien employee directory web app and contribute to the greater human rebellion? So again, we've got a Docker container which we can start. We've got a downloadable part to the challenge, although this time we don't have source code to the challenge. So let's open up the Docker instance, take a copy of that, and we'll go and load it here. You can see that we've got this employee directory and we can search for a name. So let's just test out the functionality a bit first of all. We've got a leaderboard, so if we go to the leaderboard we can see some different names in here. So let's take one of these names and go back to the last page and search for it, and you see we get the military staff member exists. So if we search for a valid name, we get it exists. If not, it says that it doesn't exist. So we could try and play around with some injection here, but to get an idea what the challenge involves, let's have a quick look at the source code here. Let's go and look at the file that came with it as well. So we'll open up here military.xml, and you can see we've got this XML document and the district ID confidential. It's filled up with the staff, and each staff member has a name, an age, a rank, and kills. And if we scroll through the various staff members here, you'll see that we have another section, and in this section some of the staff members have a self-destruct code where one of them has the first half of the flag and another has the second half of the flag. So obviously our goal is going to be to try to retrieve this flag. This is a local flag for testing, but we're going to be testing it out on the remote server anyway. So we know we want to extract some additional data from an XML file, so we're going to go and have a look at another cheat sheet here on XPath injection. And when the page loads, we see that we have a description here. XPath injection is an attack technique used to exploit applications that construct XPath or XML path language queries from user-supplied input to query or navigate XML documents. So as usual, we have various characters that we might want to try and enter, various sample commands to try and identify if we have a vulnerability. And if we look through this, we'll find that in our case we want to do some blind injection, because if we go back here, whenever we have this leaderboard, we know that we have some more data which isn't being displayed here. We have the name, we have the age, the rank, the kills, but we also have more members, and some of them have the self-destruct code. But if we go back to enter in some information here, all we can do is check, does a user exist or not. If they exist, if they don't exist, it'll say doesn't exist there, and if they do exist, it'll say does exist. So even if we were able to inject something here, there's nowhere to produce our output to. So if we were able to find something to get the flag, it doesn't print anywhere to screen. It just confirms for us whether the condition is true. In this case, the condition being whether or not the name exists. So in that case, we need to do some blind injection, and if we go here, there's some examples. So I took one of the examples here being this substring command. So let's grab this substring command and we're gonna provide this here. So take this comment out. So all this is doing is, you can see that we're injecting here, so we're using a single quote to inject our code in here as well, and then we're giving it a condition saying or, and we're checking does the substring of, in this case this is set to user, because in their example, let's go back to their example, in their example this is an XML document with the user data in it, but in our case we have a self-destruct code that we want to use, so let's take a copy of that, and instead of user we'll say self-destruct code there, and all we're checking is does the first character equal an A in this case, and it shouldn't do. We know what the first character should equal. It should equal a C, so let's actually put in a C first of all, capital C. That should be the beginning of our flag, and then we submit that and we get the military staff member exists. So what about if we try and see whether the first letter doesn't begin with a C, maybe it begins with H for HackTheBox, and we search that and we see, okay, and for some reason we see that it does exist here. That doesn't make any sense. I'm going to go and restart the server. This seems to be a bit temperamental. I was playing around with it and this was happening earlier as well. I've had to, I mean there's no local copy for us to test this out on, but I had to test this. I had to restart this Docker image so many times just due to problems whenever it, well, sometimes due to me crashing a server, but okay, let me try and load this again. We'll take a copy of that. I'm gonna paste this here, and then I'm just gonna grab a copy of this exact string here. So it shouldn't begin with H, we know that. So let's try and load this new page. Okay, it all looks the same. Let's paste that in. And this time we submit it and we get the staff member doesn't exist. So yeah, that's really strange. Let me just test that again. So if we have C at the beginning, we see we get it exists. If we try it with something else, we'll try it with a different character, A, and we get it doesn't exist. If we change this now, so we know that the second letter should be H, so we can go ahead and change this and say we're checking the substring of the second letter, and yep, it does exist. But if we try something else, let's try and just put in 6, and we'll see that it doesn't exist. So we could go through and we could do this with each of our values. We have T, which is going to be our third value, and if it comes back that it exists, we know that's correct. If we put something else in again, we know that it's going to come back and say it's not correct. So we can keep doing this, but obviously we can only do this so far, and then we get to this stage and we know that oh, it's number 5 is the curly brace. So yeah, we get this far, and now all we know is that we have CHTB and our curly brace. So what we're going to do is just treat this exactly like we did the last challenge, where we used a script to keep looping through all the possible characters, and that's essentially our blind injection technique to get back our flag. And what's really handy is we have a script now written for the previous challenge, so I just went and adapted that script slightly to work for this challenge. So let's go and check that out. Let me take a copy of this address and let's open up exploit.py. We need to paste this new address in here. So if you remember the previous challenge, then we had something very similar here. So we know our initial flag begins with CHTB. So in this case, in fact, the count, we're going to start from 6, or well, I'll set this to length of, just in case, so it's more reusable, we'll set it to length of flag plus 1 is going to be the count to begin with. We don't want to reset the flag there. So we have our flag set, we have the URL which we could go and verify here in Burp and just see what's being sent off. You can see it's going to API search, and in this case as well, the content type, I have the content type set there to application/JSON, and it took me a long time to get this script working because I was just trying to send this post data as data here, which you normally do when sending a post request, and it took me a while to work out that you have this JSON keyword here which will actually convert this into the correct format for you. So it actually, I mean, it took me maybe 5 or 10 minutes to get to know how to extract the flag, and then it took me about an hour to work out how to correctly send the post request off here. So that was unfortunate, but it seems to be working okay now. So we're going to loop through all the characters. We loop through the underscore first because it's likely to come up quite a bit. And I had this set to uppercase just for testing actually, but I'm going to try and set this to lowercase again. I haven't actually got the full flag yet. I'm going to try and set this to lowercase and just hope that there's no uppercase characters in it like there wasn't in the last challenge, because it'll take less time to do the blind injection. And yeah, it's going to loop through, it's going to assign the post data to equal exactly what we just submitted there, except each time it goes through it's going to use another character, and then once it finds the right character, so if the user exists, it's going to update our flag, it's going to update the count so that the next time we loop around we'll be checking the substring of the next character, and it'll just keep running, just like on the last challenge. It'll keep running until we get to the end of the flag, and then it'll print that out. I'm actually going to update this to all ASCII letters, so we'll test it with lowercase and uppercase letters just first of all, just to see whether it's needed. So with that all set, let's go and try and run the exploit. Okay, jumped ahead a little bit here. I tried to run it and left record on while I went AFK for like 20 minutes and came back to see that it had crashed. Let me go back here. So it crashed, it got like 10 characters in, lowercase characters, before it crashed. So I tried it again with testing capital letters and found that T was the first character in capitals, so I inserted that here, and we're now just running through this again. I've inserted a sleep command to sleep in between each request to see if this helps it. We've now got 2 characters, but I tried restarting the server a good few times. I think this is just some server issues, because you'll remember that whenever we were trying to initially test this here, we had to restart the server to even get the condition working. So some server issues anyway. Hopefully we'll be able to get the rest of the flag here. Okay, yeah, so that crashed again, so it's got stuck on U. You won't have noticed it too much in the video there because I skipped through it, but it got stuck on U for a good few minutes. So maybe there's some issues with the way I'm doing this, but we know that we have TH now. It didn't find E, either lowercase or uppercase, so I'm going to assume the next letter is going to be a 3, the next number in this case. So presumably after this we'll have an underscore. Let's just try and run this again quickly and just see if we get an underscore. Yeah, test an underscore, and it found that an underscore was correct there. So I could keep looping through this and just, keep doing this until it works. It's kind of unfortunate that the server keeps crashing, but I think the command's okay. Maybe something to do with the position here. Maybe I should be changing this. Okay, yeah, so it did crash out again. I'm going to try maybe again when the servers are a little less busy later. I might just try and keep things running in the background as well, maybe extend the connection timeout limit. But the solution definitely seems to be working anyway. I mean, we've been able to retrieve the first few characters, so as long as we can continue in this fashion, we should be able to get the rest as well. Okay, so I left the program running for a while. I ended up putting in a sleep delay of 1 second, and also added in this try catch as well, so that if it did miss out a character, we didn't have to restart from the beginning again. And yeah, got most of the flag here, so we're right up to the end of the first part. You'll see here that to get through this a little bit quicker, what I was doing is, rather than checking all the characters, if I saw something like the letter L, I would check for things like E.Tree, O, A, things that are likely to show up there, and that kind of helped speed that up a bit, the kind of semi-manual process. I've also updated the query here as well, so this is a bit more specific. So if we go back to our military XML, you'll see that we have our first part of our flag, and it's actually, if we have a look at our districts, we've got the first district, and then we're in the second district. So we've just specified here that we want to look at the second district, and then in terms of staff, we're looking at the third member of staff, and then we're grabbing the self-destruct code. So maybe that's helping cause less issues with the server as well, but at this point we need to get the next part of the flag. So I know there's an underscore here. Let me just run this just to show. If we run Python exploit, so all we're passing in is an underscore, so it's detected that that is correct. So we can now put in an underscore, but I did then try and run through all of the characters and didn't find the next part. So we now need to move into the next section, which is another district over and is a different staff member as well. So this one's in the third district and is the second staff member. So let's try and change this from 2 to 3 to 3 to 2. And then the next character, rather than just looking for an underscore, we'll be looking through all of the characters to find this. So I'll come back once we find the next character. Okay, so I ended up just running through the rest of that and getting the full flag. It did take a while. At the beginning I hadn't reset the index here, so I was starting to count from the 22nd substring index, which was causing some problems for a while. I kept looping through and not getting any results. So I sorted that out anyway, just created a flag part 1 and ran through it. And I also found that while I was running through it automatically, I would run through it automatically, and then while it was running through automatically, you could go to the site and just try and input the most likely characters here, and then if I got the most likely character right, I would then just move on to the next character here and reset the script. But anyway, it took a lot longer than I would have liked, particularly because of the throttling which seems to happen on the server side. I'll be interested to see some other walkthroughs for this afterwards, some other write-ups to see if other people had similar problems with the server. So yeah, that's this challenge anyway. I'm gonna move on to some other categories and try and get some more challenges done. If there's time, hopefully I'll get back and take a look at the DAS challenge and maybe some of these other web challenges which I didn't get to take a look at yet.
The final web challenge we're taking a look at is called Bug Report, and it says, they say humans shall not take control of any of their resources. Can you prove them wrong without letting them know? So we've got some files to download, we've got a Docker instance to spawn as well. Let's go and take a look at this locally first of all. The CTF actually ended last night. I was working on this challenge and making good progress, and I thought that, well, the timer said it was going to end at 1 AM UK time, and then suddenly it ended at 11 PM, so it was like 2 hours shorter than I expected it to be. So unfortunately didn't get this one in time, but I just wanted to come back and record this as a final challenge anyway. So let's open up the code here and we'll start a Docker instance as well. We'll go and test out the site here, and we've got this page, report your bug, we keep our systems secure, no human should be able to gain access to our systems and take control over us. Report now any bugs you have found by placing the URL in the field so we can still have the upper hand. So we might want to try and just quickly enter in some different values to see what we can do. We get there something went wrong, could try and put in a script. And again something went wrong. So we could have a look at the source code here of the page, but we might as well just go and have a look at the server side source code as well in Docker, in Codium. So we have the challenge here, we've got two files, app.py and bot.py. So let's take a look at app.py. So we load the, if we just go to the home page, it'll load the index.html. We can send a post request to API submit, which is going to be this form field. And whenever we do that, it's going to take the URL. So let's go and have a look at in Burp Suite there as well. We can see that the URL is passed as a JSON object. So we have here request.json.get, and it's taken the URL. It's making sure then that the URL begins with HTTP or HTTPS. Otherwise, it will say something went wrong. And if it does begin with HTTP or HTTPS, then we'll get this visit report, which is part of the bot file. So let's go and take a look at the bot.py as well. See, we have the Selenium drivers imported. Whenever the visit report is called and it takes in our URL, it's going to launch a browser with most of the protections disabled by the looks of it. It's running no sandbox, headless, etc. It's going to load the same page, so it's going to load this page again, and then it's going to set a cookie which is going to have our flag in it, and then it's going to try and request the URL that we provide. It's going to wait for it, and then it's going to finally return. So let's go back here as well. If we go back to app.py, the other thing that we have is if we get a 404, it's going to return this value. So we have a classic XSS vulnerability here. We are able to provide a URL, and the URL that we provide is going to be opened by this Selenium bot, and there's no protections enabled on it. And we know that before it's going to set a cookie for this document, which is the page that we're on, and then it's going to visit our site. So we want to try and steal the cookie that it's just created by redirecting to a site that we control. So we could go and play around with this then and put in some different values. Let's try and just put in, first of all, the same address. So 1337, and let's just say, if we try and enter this in, because we need to put HTTP or HTTPS at the beginning in order to get back, hopefully it'll come back and say thank you for the valuable submission. If we go and have a look at Docker, we can see that that went through, but we want to try and do something. There's nothing to show that our code has been executed here. We need to return something or do some kind of test to make sure that the cross-site scripting is working in the first place. So let's go and work out exactly where the cross-site scripting vulnerability is. If you go back to our app.py here, you see there's only one point in which the value we enter, the URL that we provide, is actually going to be written as an output, and you can see here that it's actually inside HTML tags. So if we trigger a 404 error, it's going to print whatever URL we provide there, and that's the only way we can get that to reflect. So let's go and test that out. So we didn't get a script, we didn't get anything popping up here as we wouldn't expect to, but if we give a URL which doesn't exist, so let's say here, I'll just put in here test, and then submit that, and we don't see anything, but that should be causing the 404 on the victim's machine, or inside the bot basically. So in order for us to test that out, let's just go to another tab, and this is the URL that they'll be trying to load. So let's just copy that, and you'll see that we get our XSS there. So we need to try and verify that this is even working. So one thing we could do is try to load a resource from this URL and see if it comes up in the logs. So rather than putting in a script here, I'm going to put in, let's do image source is equal to, and we'll paste in this URL and then just give it a different, so we'll say success. If the XSS is successful, then it's going to make a request to this success URL as well. So we'll just try and send that off. Click report, and this is what will be running on the victim's machine, and you'll see that we get our 404 for the test, and we provide that command with the image source, and then right after that we get the get request for success. So that means that whenever the victim is processing the URL, they load the URL, and then the XSS is successful, causing them to also try to load an image from themselves essentially, but it's just a way of us testing to make sure that that's working properly. So there's a variety of ways that we could retrieve the cookie from here. One of the most common ways would just be to set the document.location. So we'll say document.location is equal to, and I'll just provide in this case, this would be the attacker URL or the URL of our server or domain that we want to send the cookie to. In this case, we'll just send it here. We'll say a cookie is equal to, and then provide it document.cookie. And that should print us out the cookie in our HTTP logs. And you'll see here we have test cookie flag is equal to, and then it provided our local flag.